Polynomials, the cosmic cut of the universe. Polynomials. They are everywhere. You might think they are just a set of boring equations scribbled on a board, but no, they are the very fabric of the mathematical cosmos. Let's take a step back. Imagine the universe as a giant, infinitely complex symphony, and polynomials. They are the musical notes, the structural backbone that dictates how the melody of numbers flows through space-time. But what exactly is a polynomial? Let's break it down. Definition of a polynomial is an algebraic expression built from variables like x, y, z, or perhaps the hidden coordinates of a parallel universe. The coefficients, numbers that whisper interactions to those variables. For example, px is equal 3x squared plus 5x minus 2. Looks simple, right? But beware. Behind this simplicity lies a mathematical black hole of interconnected ideas. The grand structure of polynomials. Every polynomial follows a sacred blueprint. Its general form, px is equal an, x has a coefficient n, plus an plus n minus 1, plus etc. plus a1x plus a0. Here's what's happening. An is the master coefficient, the general commanding officer of the equation. N is the degree, the all-powerful rule that dictates how dominant each term is. And let's not forget, an is equal 0, etc. because a polynomial without a leading term is like a spaceship without an engine. The hierarchy of polynomials. Polynomials come in various forms, each with their own unique power. 1. Constant polynomial. A lone pair, unshaken, unmoved. Example, px is equal 5a. Mathematical monolith. 2. Linear polynomial. The first degree, the first step into the abyss. Example, px is equal 2x plus 3. Quadratic polynomials. The realm of parables, curves that dictate the laws of motion. Example, px is equal x squared minus 4x plus 7. 4. Cubic polynomial, the third degree polynomial, where things start to twist and turn like a chaotic dance of the cosmic. Example, px is equal x cubed plus 2x squared minus x plus 1. And beyond that, higher degree polynomials, equations so powerful, they govern planetary motion and control the secrets of quantum fields. Polynomial operations, the alchemy of mathematics. Now, the real math science begins. We can add, subtract, and multiply these mysterious entities to create new forms of mathematical energy. Addition, in the parentheses, 3x squared plus 2x plus, in the parentheses, x squared minus 4x plus 1 is equal 4x squared minus 2x plus 1. Simple, huh? You're merely scratching the surface. Subtraction, in the parentheses, x cubed plus 2x minus 5 minus, in the parentheses, x cubed minus x plus 3 is equal 3x minus 8. Do you see? Numbers bending and warping, transforming into the new beginnings. Multiplication, in the parentheses, x plus a times, in the parentheses, x plus b. And thus, we create new worlds. Growth! The polynomial universe is ever evolving. The final revolution. Polynomials, they are more than equations. They are codes of reality, whispering the mathematical truths of existence. The question is, will you dare to unlock their full potential? Until next time, stay curious, stay mad, and keep questioning the universe. Zero polynomial and constant polynomial, the hidden truths of mathematics. The mythical world of polynomials? Today we will explore two seemingly simple yet deeply philosophical entities, the zero polynomial and the constant polynomial. Zero polynomial, the void of mathematics. Imagine absolute nothingness, a vacuum, a cosmic void where no numbers roam, no questions flourish. That, my dear listeners, is the zero polynomial. Px is equal 0. This means no matter what value we assign to x, the result will always be 0. Definition: a polynomial where every coefficient is 0. Mathematical representation: a0 is equal, a1 is equal, a2 is equal, a3 is equal, etc. is equal, A0 is equal 0. It is the mathematical embodiment of silence, yet, ironically, it plays a critical role in polynomial operations. Constant polynomial, the unshakable entity. Now, let's step into the opposite realm, the world of immovable, unchanging numbers. The constant polynomial is like a mountain that stands undistributed by the variables. Px is equal A0. Here is what makes it special. A0 is a fixed number, a lone survivor in the equation. Every other coefficient is 0. A1 is equal, A2 is equal, A3 is equal, etc. is equal, A0, An is equal 0. But unlike the zero polynomial, here A0 is equal 0. This is the mathematical version of a single internal truth, unchanging, undeniable, and absolute. The zero polynomial represents absolute emptiness, while the constant polynomial stands as a pillar of unvarying certainty. One symbolizes the void, the other symbolizes the immutable. Together, they form the two extremes of polynomial existence, and between them lies the infinite complexity of mathematics. And now, dear thinkers, the question remains: of zero is nothing, the constants are everything. Then, where do we stand in this vast equation of the universe? Until next time, stay curious, question everything, and embrace the madness of mathematics. Welcome, everyone. Polynomials. You think they are simple? You think they are just harmless algebraic expressions floating in the mathematical abyss? Think again. Today, we are not just going to identify polynomials, we are going to expose them. The rules of being a polynomials. First, let's lay down the law. A polynomial must 1. First, have only non-negative integer exponents, no fractions, no negatives, no radicals. Second, be a sum of terms with variables multiplied by coefficients, no weird functions, no divisions by variables. So let's investigate the suspects on the board. Polynomial investigation begins. First, Px is equal 2x plus 3. Yes, a simple linear polynomial. Classic, safe, no crimes detected. 2. Px is equal 2 squared plus 3x plus 4. Yes, quadratic polynomials. It obeys all the rules. 3. Px is equal x minus square plus 2. No! Negative exponent alert! This is an outlaw. 4. X is equal root x plus x squared plus 1. No! A square root in a polynomial? Unacceptable! 5. Px is equal x coefficient 8 plus 4x coefficient 9 plus 7. X coefficient is 3. What do I think about? Yes, high degree, but still a perfect polynomial. 6. Px is equal to, yes, a constant polynomial, the simplest form of stability in the chaos of mathematics. 7. Px is equal 1 over x plus 2x. No! A variable in the denominator? Polynomials don't do that! Polynomials are not just about numbers and variables. They have structure, they have order, they follow laws. Some of these expressions on the board try to deceive us, but we caught them. Now, thinkers, ask yourself, is the universe itself a polynomial equation? Or are we living in an unsolvable function doomed to endless complexity? Think about it deeply. Until next time, stay curious, question everything, and embrace the madness of mathematics.